One of the benefits of speaking so late in the conference is I get to see my friends, so we are not strangers anymore. So hello, friends. First of all, I want to start with a question that I've been curious about. How many of you came to React Native from native development? Please raise your hand. And how many from front-end JavaScript? Wow. 50-50, I say. Oh, good to know. So finally, a real stat. So today, we're going to talk about how to implement those graphics, SVG graphics, inside a React Native app. So we're ready to talk about SVG? Let's go for it. So my name is Ori. I'm a software developer at a company called Capriza. So for the last year or so, we've been very busy doing React Native. I'm going to talk about it a little bit. But before that, I was busy doing front-end development for a few years, and before that, Android native development. So I kind of got the grasp of both worlds, native and front-end. If you want to look me up on social media, Twitter, whatever, this is my handle. One more thing. I came from Israel, which is pretty far away. So quick note about Capriza, the company I work for. So Capriza is a company, and we made the system called Approve Simple, which consolidates approvals from various IT systems in an enterprise. So we sell to enterprises. We built an app from the ground up in React Native for the last 6 months. This particular app we built in the first 3 months. We got it up and ready in the App Store. And it all evolves around this nice carousel. So we had a lot of good journey with the flat list and scrolling. You can ask me all about it after. So today's talk is going to be a two-part talk. We're going to first start off with some basics about SVG and vector graphics, talk about what's happening in the web and what's going on in a native and React Native. The second part, I'm going to share some stories I have regarding animations with regard to React Native SVG. So let's start off. So how many here are familiar with SVG from the web? Wow, great. So I'm going to quickly cover it. Before we're talking about SVG, let's talk about vector graphics. Why do we care about vector graphics? So if you care about complicated graphics, complicated visualizations, right now in our plain React Native app, you have the view object, which is, you can style it. You can style the height, the width, border, shadows. But it's pretty much it, right? Pretty much limited in the sense of what the designer is providing in his tools. You can also go with images, but that's also limited. You cannot control the color of the images. It won't scale. You have to put in an image for every resolution and every screen size. If you want to do animations, then forget it. You have to add an array of images and to pose a burden on the bundle size. Also, very important, most chances that your designer is already using some sort of vector graphics-powered tools, such as Photoshop, Sketch. And that's actually, those considerations apply for all platforms, not only mobile, web also. So that's triggered this SVG in web too. So what is SVG? It stands for Scalable Vector Graphics. It's been a web standard for a while, since 1999. It's pretty old. What it is actually XML-based markup graphics. So we all love XML-based markup. It's the parent node and the child node. HTML works like that. The native works like that. Of course, React and React Native. Very simple to use. Actually, there are some amazing stuff that you can do just with SVG. I don't know if you're familiar with this graphics, but that's actually SVG. So we can just hit up the inspector for all of you web developer. Let's see. So you can see that it's compounded of 1,000 of elements. And you can start playing around with it, see what happens. I really enjoy it. And there is a very good documentation on web in MDN if you want to learn about SVG. I really recommend you check it out. It's very friendly written, unlike W3C documentation in usual. If you check it out, you are covered in terms of knowing SVG. So some basic example in web, a little bit of web code. We haven't seen web code here. So just a little bit. You have the wrapping element of SVG. It has several attributes, to name a few: width, height, all documented. Some basic shapes, rectangle, circle, text. There is a positioning system, which is kind of similar to the absolute positioning system of CSS, with the top left corner coordinate of 0, 0. And as you go to the bottom and to the right, you get the positive x-axis and y-axis accordingly. In this example, you can see the blue rectangle positioned on 2.5 and 2.5 coordinates. One special element to note, and actually this is where all the magic of SVG lies in, is the path element. So path element, what it is actually, it have the D attribute, which is a series of commands, the originating point of M, and then a series of commands of lines and curves. This is actually what enables to draw anything on screen. And this is a very, very simple example. There is this line. It's originating some point, 2 and 2. And those are two shortened ways to write the curves. It can get complicated really, really fast. Just see this naive-looking icon, and this is what it takes to draw it. So a little bit about that later. Moving to native. So actually, native graphics already are built upon vector graphics techniques. So even when you just draw a default button, it draws into a canvas in some sort of vector graphic way. It has to be like this in order to support the various resolutions and screen sizes. So on Apple, there is a core graphics, and on Android, the Android.graphics. Just an example, for all of you Android native developers might find this familiar. If you want to draw, you want to bypass all the default widgets, you want to draw directly to the screen, so you extend the drawable class, and inside the draw method, just as you saw the series of commands of the D attribute in the path, you see a series of method invocations to draw a path element. Over the course of time, there were some abstractions on top of it. There is a very famous third-party plugin in Apple called Macau. And on Android, actually, the official SDK already have a new library called Vector Drawable, relatively new, which starts to look like SVG in terms of markup language and elements. However, those are different elements, not SVG. So React Native. Actually, React Native ships with the vector graphics library called Art. It's not exactly SVG. It uses different components, but it's in React Native, and it works cross-platform. On iOS, you have to manually add it because it poses some sort of burden on the bundle size. Another way to go, and actually the more recommended way, is to use this package called React Native SVG. I'm going to talk about this package from this point on. Some word about this package. It's maintained by these two main contributors, Magic is Might and Mikhail Sand. And what's good about it, what's beautiful about it, it's conformed exactly to the web standard of SVG. So if you know SVG from your front-end days, you know SVG in React Native. And that's the point of this package. It's already included in the React Native community. You can import it straight out of Expo if you're using Expo. It has rich documentation. And it even supports touch events, which is very important in mobile apps. So this is the same example that we saw in web. This is in React Native SVG. So as you can see, it's the same thing. We're using the same elements. We get the same result with the same attributes. Another neat thing that you can do with SVG, and this is done in React Native SVG, is some tricks you can do with text. So we are using the depth element, which you can draw elements inline without drawing them on the screen. And by using the text path, we can just refer to the path element and make the text flow across that path element. So a quick note about what's going on under the hood. So a regular native view bridge, as you may know, consists of a view element on the JavaScript side, which maps to some elements, some objects on the native side, mainly the view manager and the view. So every view on the React Native side maps to a view on the native side. However, in React Native SVG, things work a little bit differently. So for every view or for every element on the SVG, it doesn't map to a view. It maps to the shadow node. We saw in Ram's talk there is a shadow thread. So in the shadow node, it manages the imperatively calling of the canvas. So basically, it's a class that what it does, it draws into one global canvas on screen using the path element that it invokes. However, SVG is a lot more than just basic elements, right? We can do rectangles and circles without SVG. But one of the most popular usages of SVG is drawing charts. So I hope by now you're all hypnotized, and I can say whatever I want now. So when one talks about charts, the word D3 comes out really fast. So how many of you here are aware of D3? Yeah, I was expecting that. So quickly, D3, a JavaScript library for dynamic data visualization. It's originally made for the browser, and it has browser APIs inside it, so you couldn't use it outside of the browser. But as of version 4.0, they made some module separations, and some of the modules just generate data. So other platforms outside of the browser, such as React Native, can now use D3 in order to generate those long D attributes and use them. So we're going to see some example. We're going to show an example regarding pi. Let's take the pi example. So suppose we have like a demo data, an array with 3 items. Every item has a number and a color. So we start with a wrapping SVG element. And for each item in the array, we create a path element. And for the D attribute, we are using the D3 API. So I'm not going to dive too much deep into the D3. It's a reason for a different talk. I really recommend you to check out Shirley Wu's talk from React Amsterdam. I think it was this year. Shiri talks about how to code D3 with React and how it behaves with the state and the component. Really highly recommend it. So this is how we get the pi rendered. So that was like very quickly an SVG overview. So what I'm going to talk about now is how to animate those. So those graphics are really boring if they're not moving on screen, right? So let's talk about animations. So first, the good news is we get to use the animated API that we all love, hopefully. We all know that in order to use animated, we need to create animated values, those numerical values that we can animate from one value to another value. We can even, if we want, we can even animate string values by using the interpolate. And it even lets us add some text to it, which the style sheet sometimes uses. So as long as it's parsed right on a JavaScript parser, then it works. However, what happens if we have to animate between those values? We saw that that the path element is using these long values. Those cannot be interpolated. The interpolation API is not supporting these long string values. Or some other elements, such as the rect, which have all sorts of attributes that received objects. For this, in this example, an array, 2 items in an array. And then what happened? How can we animate that? So those are the challenges that I faced in the last few months doing SVG in React Native. So I'm going to cover like 3 use cases in animation that hopefully will give you some tools to overcome those challenges. So first, let's talk about the basics. So a basic example, we just want to animate a single value. So no problem there. I just want to show you that it does work on a default case. So we are animating the x value of the rect. We are creating animated rect. And we interpolate the 0 and 1 to 5 and 2 and 20, and we push it to the x value. So that was a simple case. But suppose we want to animate the pi. So in order to animate the pi, as I told you, the pi consists of several slices. Each slice is a very long and complicated D attribute. So how can we animate that? So what I did, I took a look in the D3 APIs, and I looked for some value that I can increase over time, a single value that I can increase over time that will let me animate it. So I found that multiplier of the end angle in the pi API, whatever that does. And if I increase it, the pi gets more percentage. So this is what I did. In order to do that, I'm using a wrapping element called slice, creating an animated component out of that. And the animated value is 0.1 until 2, like we saw. That's the multiplier. And I'm going to push that animated value into that animated slice. And slice is a very simple wrapper around the path element that we saw. And I'm just going to propagate the animated angle into the create by slice method, which now looks like that. So it receives a third parameter. Now it will invoke the D3 API with that additional parameter. So this is how we get the animation. A third use case. So that's a rect element in SVG. And what I did here, I did some manipulations on stroke. There are various strokes attributes for SVG that you can manipulate in order to get this effect with the underline in one state and the entire border drawn on the next state. So what we want to do is we want to get from this state into that state. So we have to change few properties, right? So they're all stroke properties. So the first few properties, no issues there. They receive single values. The first receive numerical values. The second receive the string value. So no problem interpolating that. However, the stroke dash array receives an object. And how can we animate that object? So what I did here, I had to drop the declarative approach and move to imperative approach, which is kind of a reasonable hack in animations. I'm not using it on the prop level of the component. Instead, I'm using another API of animated value called addListener. I'm using a value xy, animated value xy, in order to create 2 values instead of 1. And for every tick in the animation, the listener gets called. And I imperatively using the set native props on the ref element. And this is how I just change the value. So so this is another technique, how to overcome the interpolation challenge. So those were my 3 challenges in animating React Native SVG. There might be other challenges that I didn't encounter. But I got to a point where I just randomly looked for cool animations on web. And within 10 to 15 minutes, I just threw it in my React Native app using one of those tricks or techniques, if you want. So some of you may ask whether those animations support use native drivers. So we all strive to move all the heavy lifting of animations from the JavaScript side into the native side, right? So the bad news is, bless you. The bad news is it's not supported yet. However, it is very much work in progress. So if you can check out this work and inside the repository of React Native SVG, you can see already a working example. It's done in a different branch. But it's a working example of animation on a React with, guess what? Use native driver true, if you can see it. So there is hope. You can check out those examples in the GitHub repo that I made for this talk. And hopefully you saw some cool tricks that will let you use React Native and SVG. And what's important is you can just leverage your knowledge or already existing knowledge from web regarding SVG inside the React Native app. Thank you. That's my talk.